Hi everyone, we are FuVeX and we are automating the powerline inspections. In this project, Autonomous Edge, we are automating the data capture in powerline inspections. So there are over 5 million kilometers of power lines in the European Union. These infrastructures are critical to bring energy to European society and industries. These types of inspection need good quality high-resolution images to understand the health of infrastructures and its key elements. On the left, you can see the camera is pointing to the key elements. So the photo will be giving us an idea of the current state of, for example, insulators, joints, etc. However, many times when you are flying long-range drones, the result is not always the right one. The photo on the right shows how the camera might not be pointing to the inspection area because of the wind, some GPS problems, etc. So what we have developed in this project is a system in which, by combining computer vision and machine learning, we are able to detect the powerline tower with a low-resolution camera and an onboard computer. This allows it to run real-time, and then, after calculating the position of the tower, the gimbal with high-definition visual and thermal camera will be commanded to point on the right direction. To develop this project, we have divided it in 3 stages. The first one being validation lab. As you can see in the video, we simulate the drone flying by moving a picture of a power tower. The low-res camera seems to be pointing on to the tower. It is remarkable that the video is making these jumps due to the core of the pointing algorithm. To command, the onboard computer needs to know the global position of the gimbal, so the jumps are required to achieve this by waiting for the mavlink messages. With this test, we reached TRL 4 on the project. After that, we went to the second test, which we performed on a relevant environment. The goal here was to be able to point only one tower and to check if everything that we made in the lab was viable. The test just consisted of a takeoff maneuver, some basic yaw and pitch movements, and then we land. For the final stage, we have performed different tests to accomplish the operational environment validation. They were done in a Zagra, in the power line of the area, and as you can see in the mission, there is no pre-appointment design. The yellow points represent the mission's waypoints. I have overlaid the high-resolution video from the wireless camera with the low-res footage taken from the onboard computer. As you can see, the appointment is being done every few seconds. There is a little bit of deviation because of the different point positions of the cameras. After the vehicle passes by, the algorithm relocates the camera to an optimal position to restart the appointment. And here you can also see the thermal camera pointing to the tower. To sum up, we can extract from the project the development of some key elements in visual and thermal data gathering, such as convolutional neural network to detect power towers in real time at the edge, computer companion system with a core TPU's image processing acceleration at the edge, image processing algorithm to evaluate correction angles to position the inspection camera, and finally, integration of the pointing system with the gimbal on board to move it to a final position by using mavlink protocol. So overall, a low-cost and low-weight system which points on the fly inspection cameras to take photographs of power towers from a VTOL drone. And of course, our goal is to keep working on this project to be able to reach an TRL 9 application. We consider these following steps to be required. To raise a 2.5 million in funding to continue the technical development of FuVeX cores, such as regulation, aircraft, data capture systems, being this system part of the last core. Classify more datasets of high voltage and medium voltage power lines and train the network. Ensure results reliability in more complex scenarios, such as power line crossing, vegetation, etc. And industrialize the computer companion system on the edge. So thank you to the ELISE project and the European Union for supporting this project and for making it a reality. Thank you very much.